Welcome, and thank you for supporting this Patreon project. This video explains how I installed and configured the G-code for the P1 SteinWipe. I will go into detail about how I configured the SteinSwitches to tailor my printer's startup routine. In the next video, I'll go over how I configured a pause routine in a way you've likely never seen before. At the time of recording this project's still very new, and I've only been able to test it on my non-AMS P1 series from Bambu Lab. So you can expect to see more files and videos in the future covering additional features and machines. By the time you finish watching this video, you should understand the entire process of setting up the P1 SteinWipe, but before we get into it, you should understand the risks involved in modifying your machine's G-code. In this video, I will do my best to provide clear instructions to minimize the possibility of an error in anybody following along. However, you should only proceed in such a mod if you feel comfortable making changes to your machine's G-code yourself and you accept all the risk involved in doing so. This video is for educational purposes and I cannot guarantee any outcome. Participating in the activities seen here may result in your machine performing undesirable behavior, which such events could lead to permanent damage of your machine or even injury, so follow along at your own risk. With that out of the way, let's get into it. Once you've downloaded the project files, they will be in a single zip, and unpacked it'll look something like this. And if you're from the near future, you will see these additional files. A quick overview of everything that is here. The G-code folder contains everything you will need to drive your machine to use the wiper mod. The model files is everything that you need to get your mod printed. And the RPT, or ready to print files. These are pre-sliced files that will work on a P1 series running Bambu PETG filament. You can simply just drag and drop these on your machine's SD card and then press print. That's it. The pause is already included in the backing plate for adding the hardware. I'll start by navigating to the G-code files, right-click on the startup code, and then open it in a text editor. I'm on a Mac here, so I can set my default program to text edit to make this easier to open again later. I'll mention these files are G-code extensions. You could literally take one of these files, drop it on your machine's SD card, and then run it right from the machine without ever going through the slicer. This can actually be handy if you want to speed up the process of dialing something in. For example, if I want to test a position, I don't want to wait for the bed to heat and the printer to go through all the motions of the startup. I can simply just tell the machine to home the X and the Y and then go to the position that I set, and then I can see what it looks like. In the old days, we used to have a terminal window that we could just send the commands to the machine directly. Unfortunately, we don't have that with Bambu, but we can still get the job done. And now back to the startup routine. At the top of this code is the release date, so make sure you check back from time to time so you're not missing any updates. As I mentioned at the start of this video, at the time of recording, I have not been able to test on an AMS machine or an X1C simply because I don't own this equipment. But I am pleased to announce that I have purchased an X1C with an AMS to expand the capabilities of this solution. I have had reports that the code in its current state will work with the AMS, but of course it will on startup. However, the point is to use the wiper mod on material changes during the print, and that will require additional code. Some of you in the community have reached out to get the ball rolling on this code already, but if I'm to offer an official release on the X1C or AMS coverage, I really need to confirm it with my own eyes and ears and understand the code. That way we can troubleshoot if there's anything that comes out of, firmware hiccups or downstream issues that may otherwise be overlooked. Moving on, if you haven't already gathered by the name of this file, this particular file is all about controlling what happens during the startup routine. The firmware that this was tested on was 01, 06, 01, 02, and it is known that the newest firmware has a dynamic auto bed leveling bug which ignores the command. I would suggest that if you've not experienced any issues with the 01, 06, 01, 02 firmware, to just roll back the firmware to this version in the Bambu Handy app until they push out a version that works. This one might seem obvious, but very fast travel moves are used in my routines, and you always do want to keep your hands out of the machine. And now is a good time to talk about the not so obvious. The P1 series, it currently does not detect the bed plate, so do make sure that you position the plate correctly, otherwise damage can occur. This goes for any startup routine, not just mine, but I thought this would be a good opportunity just to inform everyone of this fact. And lastly, when it comes to mounting the wiper, guys, I'm sorry, but you have to drill and use fasteners. Any attempt to use tape is going to cause an alignment issue, and you're probably going to end up with a bent nozzle. Also, you want to consider the temperatures in the build chamber. It's likely that tape is going to lose its grip over time. It'll start to sag and again cause some alignment issues. You're going to end up bending the nozzle at the heat break. So please do use fasteners. If we scroll down, I have a list of the features here, but we'll continue to scroll down to the first one that's encased in the pluses. Pre-homing collision avoidance. I implemented this feature to prevent the nozzle from passing through the wiper pad while it's cold, moving at homing speeds, and without proper constraints. Without this feature turned on, the travel pass will almost never be in the correct position accepted by the wiper, leading to unnecessary forces in the nozzle heat break. This can lead to the nozzle being bent. To solve this, my strategy moves the print head back to a safe position before the homing begins, avoiding any chance of it traveling through the wiper pad. The only exception is if the print head is already positioned all the way forward when the startup begins. In this case, the head will still attempt to move forward briefly with no place to go. So to mitigate this, I've configured the motors to use the lowest possible strength and speed during this movement. That way, if the head encounters any resistance, the motors will simply slip and not cause any issue. So if you encounter this, it is intended. Once the print head is moved to a safe position, the homing cycle takes over as usual. I can turn this feature on by setting the SteinSwitch to true, or return to the stock routine by setting it to false. Inspect nozzle. While the nozzle was heating up, I thought this would be a good time to bring the nozzle forward and lower the bed to do some nozzle keeping. Sometimes some strings can build up on the back side of the nozzle, so it's not just on the tip that we have to keep it clean. So this SteinSwitch gives you a 20-second window to do that little bit of cleanup before the print gets going. If you set the SteinSwitch to false, that's going to skip this section. Use less filament to prime nozzle. This section uses a better approach at getting the nozzle ready, but first let's look at what needs to happen. We need to fill the nozzle with fresh filament, we need to clear any previous filament, and we need to push out any air that's left inside the nozzle. To achieve this, I'll start by parking the nozzle on the plate while we heat it to the melt temp. This prevents any filament from oozing away, which is the first step to reducing the amount of filament that we need to purge. Once the nozzle is hot enough, I'll quickly scrape it off and then zip over to the chute and start pushing filament immediately. Doing it this way minimizes the chance of the filament curling upward and sticking to the nozzle because the stream is more consistent with less air trapped inside. And one note on that, if we let buildup happen on the nozzle, this greatly increases the sticky surface, leading to a better chance of a purge sticking back to the nozzle, and that gets dragged back into your print. So the cleaner we can keep the nozzle in general, the overall more success we'll see in purges dropping down the chute. Once the purge is complete, I quickly cool it and zip over to contact the bed as fast as possible to avoid any oozing of filament introducing air back into the nozzle. The nozzle gets a circular scrape cycle and it never lifts off the plate until it parks and cools down enough to not ooze filament. When it is finally lifted off of the plate, it is still hot enough that the filament is still soft and it can be removed by the wiper pad, and then it will come back and park on the plate again to finish cooling down and then go into the homing routine. You can use this routine by setting the SteinSwitch to true, or you can use the stock routine by setting it to false. Use wiper pad at startup. This section works in conjunction with the process I just explained, but it excludes the use of the wiper pad. I assume that not everybody using this code will have the wiper pad installed, since there are beneficial features that can be utilized in the code besides the wiper pad. Setting this option to true uses the wiper pad. Setting this option to false uses the stock scrape routine, which takes place on the spring tab. Mech mode vibrations. If you don't know what this is a test that runs your machine through a series of vibration cycles, which allows the software to compensate for the inertia buildup in the motion system. Because the machine is not infinitely stiff, there is always a little bit of overshoot or undershoot that happens at high speeds. This results in visible artifacts in the walls of your prints, and the corners are not as sharp or square when they should be. When I researched this in the forums, there seems to be a little bit of confusion about how this system actually works in practice. In my testing, after a vibration cycle is performed, we can then recall the saved data on future prints, meaning that we don't have to run the test on every print. On the side of skipping the cycle, you may consider to do this if you're trying to run the printer in the middle of the night, but you don't want to wake up the entire house. but you can still reap the benefits of the compensation feature. Also, there is a small time savings and maybe slightly less wear on the machine. Likely these don't really matter. On the side of performing the test, well, first we ask, why do we even need to run the test more than once in the first place? Why can't we just run the test once while we calibrate the machine and then recall the data on every print? Well, one caveat to skipping the cycle indefinitely is the machine does undergo wear on the belts and the motion system, so these things require frequent compensation. When the machine performs a test, it knows if it's out of tune to the point where you need to actually physically tighten the belts, and it'll flag an alert for you to do so. So how does this SteinSwitch work? Well, I paired the mech mode test cycle with the auto bed leveling cycle. This seems to go hand in hand because I can recall the data from either test on any print, which means that I don't have to run either cycle on every print. Setting the SteinSwitch in this section to true will run the mech test only when I select bed leveling in the slicer. And if I don't select this in the slicer, it will skip both the leveling and the mech test to use the previously stored data. This is my personal default since I run my machines at home, usually at night, and it's convenient just to turn the calibrations on and off with one click in the slicer as I send out the file. I will let you know that I do often run my machines for the calibration. I at least run the bed leveling and the mech test once a day just to keep the machine in tip-top shape. Setting this switch to false just uses the stock method, which is to run the mech mode every single print. Use dynamic bed probe routine every print. Dynamic auto bed leveling means that we probe the bed only where the print is located. This saves time by not adding additional redundant probe points to your startup routine. Setting the SteinSwitch to this section to true means that you will use a dynamic auto bed leveling on every print regardless of the bed leveling checkbox. Setting it to false will use the stock auto bed leveling routine, which will probe the entire bed only when it is checked in the slicer. Use true pressure advance test line. The PA test line in this section is a true representation of the current PA setting for the selected filament. Setting this feature to true disables the long hockey stick type purge, which is actually positioned inside the print volume, which opens up the door to the possibility of your print being positioned over top of the purge line. Much like many of the manual PA tests that you can run on your machine, this PA line should be as consistent as possible with minimal indentation. This test line also prints 4 mm outside of your print volume, so there's absolutely no chance that you're going to place a model over top of it. Setting this feature to false uses the hockey stick style non-PA purge line. No strings to first layer. This feature allows for a better travel strategy when moving the nozzle from the purge line to the start position of your first layer. Because the first layer is usually much slower overall and uses much lower acceleration values, this unfortunately affects the speed when traveling to the first layer from the purge line. You might even find that filament has oozed away during that first travel move, resulting in it rolling up under the nozzle, leaving a small blob, creating an instance of poor adhesion where it matters the most. This feature forces the use of high-speed travels and accelerations from the purge line to the first layer by using a simple mathematical strategy for finding a travel point within the first layer. Setting this SteinSwitch to true will use your machine's maximum travel and acceleration ability to get from the purge line to the first layer. Setting this to false will use the stock method, which is using the speed and acceleration values set by the first layer in the slicer. Now, according to Joshua, all these functions are automatically done by Bambu. I might not have his keen eye, but I do have the power of denial. With this in mind, there might not be much point in you proceeding to install the new modified code. But if you want to give it a try anyway, you can compare your printer's startup behavior for yourself. These next few steps will show you how to bring that code into the slicer. In my edited text file, I simply select all and then I copy the entire code to my clipboard. In this example, I'm using Orca Slicer, but the process is the exact same for Bambu Studio. Select the printer profile that you would like to modify by making it active. Click the scribble pad. Click the Machine G-Code tab. And under the Machine Start G-Code panel, select the entire contents and delete it. Now you just need to paste the code from your clipboard, and that's it. I can now preview all the travels in this code and I can confirm that everything looks as it should. I don't see any moves going out of bounds and I don't see anything I didn't expect. With that last check out of the way, I can now send this to the printer. In the next video, I will cover how to use the P1 SteinWipe with the AMS configuration, and how to configure a printer pause using logic to give us full control over the pause routine instead of the traditional way of inserting a pause. Thank you for watching this in-depth tutorial and for supporting the P1 SteinWipe project on Patreon. Happy printing, everyone!